The future of space. Colonization, Mars and beyond. As humanity faces the challenges of population growth, resource depletion, and environmental stress on Earth, the idea of colonizing space is no longer just the domain of science fiction. Space agencies and private companies, such as NASA, SpaceX, and Blue Origin, are actively working toward establishing permanent human settlements beyond Earth, with Mars often seen as the most viable target. However, as technology advances, there is increasing interest in other destinations, including the Moon, asteroids, and potentially even planets beyond our solar system. Why space colonization? The motivation to colonize space stems from a combination of practical and visionary goals. 1. Survival of humanity. Establishing self-sustaining human settlements beyond Earth is seen as a way to ensure humanity's survival in the event of global catastrophes, such as asteroid impacts, nuclear war, or climate disasters. 2. Resource exploitation. Space offers vast untapped resources. 2. Asteroids, for example, contain valuable metals such as gold, platinum, and nickel, while the Moon and Mars may provide materials for construction, fuel, and life support systems. 3. Scientific exploration. Permanent settlements would allow for long-term research and experimentation, furthering our understanding of the universe and potentially unlocking breakthroughs in physics, biology, and materials science. 4. Technological advancement. The challenges of space colonization drive innovation in fields such as robotics, artificial intelligence, energy production, and life support systems, with potential benefits that extend beyond space exploration. Mars. Humanity's next frontier, Mars, has emerged as the primary focus of space colonization efforts due to its relative proximity to Earth and its potential to support human life. While the planet presents significant challenges, such as its thin atmosphere and extreme temperatures, several features make it a promising candidate. 1. Water availability. Evidence of subsurface ice and seasonal water flows suggests that future settlers could extract water for drinking, farming, and fuel production. To similar day length, a Martian day, Sol, is approximately 24.6 hours, making it easier for humans to adapt compared to other planets. 3. Potential for in-situ resource utilization, ISRU. Mars offers resources that can be used to create building materials, oxygen, and fuel, reducing the need for constant resupply missions from Earth. SpaceX's vision for Mars colonization. SpaceX, led by Elon Musk, is at the forefront of Mars colonization plans. The company's Starship program aims to create a fleet of reusable spacecraft capable of transporting cargo and humans to Mars. 1. Initial missions. SpaceX plans to launch uncrewed missions to Mars to deliver infrastructure such as habitats, power generators, and life support systems before human missions begin. 2. Self-sustaining colonies. Musk envisions the establishment of a city on Mars that could grow to house over 1 million people, with the long-term goal of creating a self-sustaining civilization. However, achieving this vision will require overcoming numerous obstacles, including radiation protection, food production, and psychological challenges related to long-term isolation. The Moon, a stepping stone to the stars. Although Mars garners much attention, the Moon is often seen as a practical first step towards space colonization. Its proximity to Earth, about 384,400 kilometers, makes it an ideal location for testing technologies and building infrastructure. 1. Lunar resources. The Moon's surface contains significant amounts of regolith which can be processed to extract oxygen and metals. 1. Additionally, water ice deposits at the lunar poles could support life and fuel production. 2. Gateway to deep space. NASA's Artemis program aims to establish a sustainable human presence on the Moon by the end of the 2020s, with plans to use the Moon as a launching point for missions to Mars and beyond. 3. Lunar bases. Establishing research bases on the Moon would allow scientists to study its geology, explore potential mining sites, and test life support systems in preparation for longer missions. Asteroids and beyond. Expanding the frontier, asteroids represent another important target for space colonization due to their abundant resources. Mining asteroids could provide raw materials needed for building structures in space, manufacturing spacecraft, and supporting life. 1. Asteroid mining. Companies like Planetary Resources and Deep Space Industries have explored the potential of mining asteroids for metals and water. 1. Water extracted from asteroids could be used for drinking or split into hydrogen and oxygen for rocket fuel. 2. Space habitats. Some concepts involve building rotating space habitats, such as O'Neill cylinders, using materials harvested from asteroids. 2. These habitats could support large populations and provide artificial gravity. Beyond asteroids, scientists are also considering the feasibility of colonizing moons of the outer planets, such as Europa, a moon of Jupiter, and Titan, a moon of Saturn, both of which have subsurface oceans that could support life. Challenges of space colonization. Despite its promise, space colonization presents significant challenges that must be addressed before permanent settlements become a reality. 1. Radiation exposure. Space travelers are exposed to higher levels of cosmic radiation, which can increase the risk of cancer and other health issues. 1. Effective shielding and medical countermeasures are critical. 2. Life support systems. Developing reliable systems for air, water, and food production is essential for long-term survival. 3. Psychological and social challenges. Prolonged isolation and confinement can lead to mental health issues. 3. Ensuring the well-being of colonists will require careful planning and support systems. 4. Cost and sustainability. Establishing and maintaining colonies will require significant financial investment. 4. Sustainable practices such as resource recycling and local production will be crucial to reduce dependency on Earth. The role of international collaboration. Space colonization is a global endeavor that will require collaboration among nations, private companies, and international organizations. Joint efforts can pool resources, share technological innovations, and establish regulations to ensure peaceful and ethical space exploration. 1. The Outer Space Treaty. Existing international agreements, such as the 1967 Outer Space Treaty, provide a framework for the peaceful use of outer space. 1. However, new policies may be needed to address resource sharing, property rights, and environmental protection. 2. Global space initiatives. Programs like the International Space Station, ISS, have demonstrated the value of international collaboration, which will be vital for future missions beyond Earth. Conclusion: the future of space colonization holds immense potential for scientific discovery, technological innovation, and the survival of humanity. Whether on Mars, the Moon, or distant asteroids, establishing permanent human settlements beyond Earth is an ambitious but achievable goal. By addressing technological, environmental, and ethical challenges through global cooperation, humanity can embark on a new era of exploration and secure its place as a multi-planetary species.